Okay.
Okay, that's the wrong one. Now, do you see the good one?
Yeah, this is okay.
Okay, thank you, David.
So I just, as I just said, we try to turn replicability upside down. And so the next slide, please. And we are gonna do this flipping thing slowly. So in theory, and especially in most philosophy of science theory, replication and reproduction of observation is a prerequisite. Of course, as the whole Felipe's talk yesterday has shown, different definitions and categories are at stake around replication in philosophy of science. But if we take it bluntly, the general view is this: any scientific activity, being experimentation, data production, or analysis, is supposed to be not only good, but necessary to the truthiness of scientific claims. So here how it goes. One group of scientists using some kind of instrument, stating that it finds something as a fact, its methods are described, and as author, they show some phenomena through a literary technology stabilized over centuries called the scientific paper. Then another group does exactly the same experiment, following the rules just like a kitchen recipe, and they eventually come to the same results. This seems a simplistic version of the scientific research, but it actually fuels a lot of assumptions among debates about self-correction, falsification, the scientific method, and the likes in philosophy of science circles. However, next please. As investigations of concrete scientific work at the bench have shown since the 70s, experimental circumstances and uncertainty are so deep that there is a gap between science and research. Or to put it differently, science as the realm of ideas is not research in practice. Regarding replication, things are also very different in practice. We have known, at least from the 70s, especially with biomedical scandals, that very few authors bother to remake certain observations, experimentations, or calculus. It is neither exciting nor rewarding to do it. Most of the time, they take results as a given, and they move to test something different, often follow-ups consider hitherto unknown. Yet, in some disciplines, you actually remake things. For instance, in mathematics, during peer review, you actually go through the proof step by step and basically perform it again. Hence, it takes days of work for reviewers to assess an article. Another example, in computer science, where most people share some code and you can actually test it, we have observed innovations such as the clickable articles, in which code, data, and manuscript all go together. This is the prototype reproducible article pointed by Sabina Leoni, embodied into a platform. But it underlies a second dimension of replication in practice. While you have access to remake the proof, it completely occurs on the basis and infrastructure of the authors and journal, not independently. And why so? Because you actually can publish replication as by definition it's not just original and new results. Most academic journals would ask you these qualities as a precondition to consider your work for publication. Even in some initiatives that are precisely charged to suppress those two dimensions in some disciplines, such as biology and psychology, it remains a marginal movement with spectacular but limited results. Moreover, in a crowdsourced collaboration called the Reproducibility Project in psychology, try to repeat 100 published experimental and correlational psychological studies, the 270 scholars have a specific status. They are considered contributors, not as usual genuine authors. Nevertheless, replication do exist in science, as we can witness it almost every day, in contexts that are considered negatively and even threatening the whole academic world. Indeed, if specialized scribes have been devoted to faithfully copy texts for centuries during the Middle Ages, for a long time, as Andreas Dickman reminded us yesterday, replication has been seen as a problem for science and labeled as something to be avoided, forbidden, and fought in various ways. At the end of the 60s, Frank J. Ingelfinger, then editor-in-chief of the New England Journal of Medicine, introduced a new editorial policy strongly limiting the number of occurrences of biomedical information. This policy was termed the sole contribution, on the right on the screen, the sole contribution principle. According to this principle, any article submitted to the journal would be systematically rejected if most of its essential substance had previously been submitted or published in any form, book, journal, or press article. The prior publication of results in a mainstream medical journal, which until that had been commonly considered a popularization practice, was thus redefined in the name of the necessary validation of any preliminary results. It intended to report facts whose quality has been previously controlled. The journal aims to announce new, innovative discoveries that mark scientific research. It is this requirement of newsworthiness that Ingelfinger has strongly asserted by strongly fighting for the republication practice being prohibited. 15 years later, this personal initiative has led to complex norms adopted by various groups of editors and publishers, such as scope, copy, in which you grade the publication and act depending on authors' response, their institutions, the content itself, and the support intentions of co-authors. But how could you prove that something has already been published? One important characteristic of these replications is the ability to find them apart from the obvious paper everybody already talks about. In other words, you need tools, sometimes sophisticated or even sold by for-profit companies. As this screenshot reads, Authenticate is a plagiarism checker tool that allows users to identify fine-tuned textual similarities. It is so good that you can, quote, published with confidence, end quote. And if you have any doubt, it is approved by, quote, the world's top researcher, publisher, and scholars, end quote. But these tools are also need to show your journal is taking all this plagiarism thing seriously. Protecting its reputation is here at stake, and not screening manuscript as a first stage before the actual peer review is now considered unprofessional. This is why at the Crossref level, this software was implemented into cross-check on millions of articles. However, low-tech can also be a useful post-publication tool. For example, consider this 2011 Google Sheet doc to build a case of self-plagiarism from one of the most cited economists in the world. This simple tool gives readers a view on the similar or even identical paragraph taken from two different published papers, eventually showing their main difference is their title and publication output. Of course, the case is funnier when one of the papers' title is Publishing as Prostitution, choosing between one's own ideas and academic success. Such an investigation led to the authors confession that all this was deplorable, but didn't prevent him to keep his position in Basel. More important here is the label of self-plagiarism, on which vigilance towards the more or less extensive repetition of the same informational content nowadays focuses much of the attentions. This concern is directly onshore in Ingelfinger's sole contribution principle, which not only led to controlling the circulation of knowledge among scientific medical journals. Actually, it was also interpreted as a means to fight against the duplication of papers, and consequently it inaugurates an important work of differentiation. In the 80s, it has indeed become possible to distinguish a prior publication from other forms of reiteration of the same information. Repetitive, duplicate, and redundant publication have been the main categories usually used by biomedical journal editors. One way to separate good practices from bad was to characterize the motivation for duplicating results. For example, this editor-in-chief makes a distinction between 4 types of duplicators: pyramid builders, Januses, manipulators, and desperados. The first 2 are clearly a matter of proportion and gambling. Conversely, the last 2 can potentially qualify as cheating. Okay, since our dive into this dark side of replicability, at least 4 aspects stand out which do not necessarily follow a linear sequence. First, replication does not consist only in a standard professional practice. It is also a concern that is regularly stressed out and whose consequences are to be deterred and prevented. Some detection tools are gradually being developed to apprehend its various manifestations, with a co-evolution of the tools and replication forms over time. Optimists consider that Optimists consider that distracting is always more accurate.
Stavo morendo di freddo ieri.
Someone want to
please,
part of the
please cut the mic.
Optimists consider that this tracking is always more accurate, while pessimists only see the ceaseless advance of the fraudsters. Forms of replication are defined, set into categories, and the target of particular labeling. This is a well-known practice in the sociology of deviance, and what is particularly striking with the contemporary situation is the rise of these labels among the growing so-called misconduct studies. Replication as an issue constantly comes with some expression of concern, whistleblowers or alarm raiser, ethical reassertion of best practices, and so on. But in many cases, replication eventually comes with experimentation of alternative practices and the production of new publishing norms. To follow up on this, Didier is going to develop other cases that emphasize duplicated images and paper mill.
Okay, I'll go on with this because of technical questions. Of course, I have less time, but it's okay. So what David has shown you is very well known about text, but we see something that is exactly the same from our point of view on images. So in 1993, the Mayo Clinic Proceedings Editorial Board adopted a policy relative to the use of computer-enhanced photography. That was the beginning of Photoshop in academia. And they said, computer enhancement and alteration of photographic material for purpose of clarification should be done with discretion. Photographic misrepresentation constitutes scientific fraud. So, of course, then you have to build new categories of what is acceptable and this is an example photos, okay, you got scratch, you got things and that, and you can erase it through Photoshop, and what is unacceptable, like erasing something that is supposed to be important in CT scan or displacing objects. So they have categories like this that goes on from journal to journal, even before they were going fully electronic publishing. If you look what happened in the 2000s, you've got hundreds of papers talking about image treatment, especially in computer science. And here you got example, and you can play the game of 7 differences between the original and the forgery. And the idea is you forge something by taking some little a part of an image, and you actually reproduce it in another part of an image by changing its size, its orientation, its color, its opaqueness, and whatever. So you got really hundreds of paper showing you how methodologically you can actually see image manipulation and image duplication within images themselves. Of course, this, just like for text, this high tech doesn't prevent low tech to be happening. We talked yesterday about the Schoen case. So this physicist who was taken and caught, and how did it begin? It began when some scientists discovered by almost randomness that some figures were exactly the same from one paper to another, but not, of course, describing the same phenomena. Here you have an excerpt of a report made by his employer, Lucent, in the Bell Labs, and you can see it's the exact same figures, but supposed to describe different things. And when the first journal, which was actually Nature, confronted the author with that, confronted Schoen with that, he said, oh, I made a mistake, of course. I've taken the wrong image. But of course, as more and more images went up, it goes into inquiry, and we know the end of the story, which is, in fact, all of this was completely fake. And of course, inquirers didn't believe at first. At first, he had destroyed his work in order not to be copied himself. So image duplication can be done, of course, on a craftsman basis, but it can also become an industry. If we jump to 2016, we have this paper by Elizabeth Bick and co-author, in which she develops categories for duplication. So here, if you look at the green part, it's a category 1. That means you have one image and you actually just duplicate it and put it somewhere else by, in fact, using 2 different, saying this is 2 different controls, while in fact it is exactly the same, meaning that it has been used, for example, in experiment 1 and not in experiment 2, but you pretend it has. But you have also category 2s, which is, if you look at the green and the blue, you take one part of the image and you reposition it, or you change its side in another part of the image. So this is category 2 for her and her co-authors. And you got category 3. Category 3, you look at the green, green, pink, pink, yellow, yellow, red, red, and so on, is duplication with alteration. You can see the differences is not within the squares, but in the rest of the image, especially between the pink and the yellow one. So actually what she did was taken 20,000 papers, and she showed that as a mean, 3.8% of the papers had what she called problematic images. So the image itself and the fact that you can detect some kind of duplication is a problem. So duplication and replication is a problem, and you can see the distribution of journals. So the more prestigious a journal, the less proportion of problematic image you have, but it's not like a pure correlation, of course. And of course, as we've seen with Schoen, you get lots and lots in so-called high impact factor. In the same paper, she was, of course, announcing that you could go further than using her methods. And 2 years later, some scientists in computer science and image machine learning said that they created a tool that actually could spot tens of thousands of duplicated images across thousands of papers. And what is interesting is that they didn't put the open code, saying they didn't want to go without proof to accusation of misconduct for this. So it's a preprint on bioRxiv in 2018, and the paper has never been published. So we actually don't know whether that works or that doesn't work, or they thought it was too dangerous to release the code and the results in public. So that's a case, image duplication, in which you have the same kind of structure that David shown on text. The third example, and I will go quick, is paper mills. So paper mill is a word usually used in Anglo-American as something that goes with students. The idea is that you have a research report, your term paper to do it, and you don't want to do it, and somebody else is actually making it for you for money. It dates back to the beginning of the 70s. You got this beautiful paper in political science. It started really like a small shop, except that after a year, they were always having a turnout of more than $1 million. So it became really business. There were trials and so on. So this is like something that is supposed to go for students. You got people that actually know how to write and know subject, making your text, and you give students a copy of that, and all they have to do is, of course, add their names and whatever, and change just the little bits around. You get another practice that is really important, which is within the academia, which is paper ghostwriting. It's a term that has really appeared in the 70s and the 80s, become popularized in the beginning of the century. It's the idea that somebody else is writing the paper and not actually being in a byline. And this goes a lot, and you got Sergio Sismondo's pioneering work, in which that some companies actually organized this, for example, pharmaceutical companies that make the work internally and then pay doctor in order to sign the paper. You got another practice that is really important. This is paper authorship selling. So you got this Russian site that is telling you the papers have been written. We can add in the middle of the byline your name. And of course, you pay more if you're first offer, a last offer, or in the middle of the byline. And in the middle of the byline. And you got the China's publication bazaar, in which the exchange of authorships and papers against money is really described as common in this Science 2013 paper. But the problem, of course, is that some of these papers are genuine paper. You just play with a byline, and some of them are not. And this really, if you look all these together, that goes to the paper mill for academics. This really, really good paper by two Chinese authors, Yu and Chen, shows that this is on a campus, and 4 of the 6 ads here are actually ads for paper mills. That is, we can give you a paper in Science Citation Index, SCI, or Social Sciences Citation Index or Engineering Index. Just contact us on this phone. And this is, in fact, a practice that is aimed at clinical doctors' research, who actually are doctors, and they are doctors by the bedside, but they're supposed to do research. They're supposed to make paper, and they have no time to do it. And they show also there's a leniency toward research misconduct at that time in China. So that led to paper mill. That means that tens, hundreds, and soon 1,000 papers were considered as fabricated in some paper mill. In 2018, this is the first slide, you've seen it. So Phelps press editors discovered that identical images were being submitted by different authors to different journals at the same time. So it could be considered as image duplications, except it was 12 papers coming from China, which was considered a large number then. And you can see they found it because first time it was the text similarities that were striking through the software, and the texts were really well worked. it was not copycats. The papers were really intriguing. So they looked at everything, including images. And you count from 12 papers, and 2 years later, you can see the last line, 546 papers, working with the same images and the same kind of things. But of course, it's different authors, and it's different subjects that are supposed to go, and different publishers. You can see different journals, different publishers, and so on. And you got the affiliation department. It's all clinical scientists, as the two Chinese colleagues had predicted. So it's a small team with Elizabeth Bick that came to unearth hundreds of papers with the same images. They were not manuscript, of course, but actual publication. So as, of course, we attend this replication crisis conference, some scholars have begun to propose ways to treat these articles coming from paper mills, where everybody right now is saying it's probably thousands of papers that have bin published that way already within the literature, especially in biomedical sciences. So the conclusion, 4 points that are important for us. First, objects replications are more and more searched and considered as biased science. We've seen that, of course, with text. We've seen that with images. We've seen that with paper mills. It could be raw data. It could be figures. It could be everything. The idea that you have the same kind of sequences, and it could be, when I say sequences, it could be gene sequences also, but it's now something that is really targeted. You just copy something, and the fact that you detect a copy is a sign of bad science that is either an error or even more misconduct. And so you have at least to redefine replication in the sense of a conference as positive replication, as a system of sameness and differences, an idea that was already in Sabina Leonelli's paper in 2018, not as the same thing. Would it be idea, results, methods, or whatever? It has to be in some part different in order to be authentic. Otherwise, you consider it just as a copy, as a bad copy, and something that is bad in science. Third point, of course, we've gone from craftsmanship, and I'm sure you have people making books and articles for you and reports for students of the 19th century in French and Italian universities, but it has become an industry of copying with lots of money to do, with crafted people that are doing things that are more and more, that look more and more genuine and crafts made, hence the uncertainty underlined by David, but is not only in the lab, but also in the process of writing and distinguishing an actual fabrication and a real paper. And so we could propose that instead of the replication crisis, you could call it the replication boom, in which ethics of science have become material and economic norms through not only the fact that you have procedures, tools, but also markets, both for companies, but also for ideas through misconduct studies. So the replication crisis could be seen as a new field in which many people are going to make reputation, positions, and money. Thank you.